Quantum computers are a good testing ground for many foundational ideas in quantum mechanics. In many cases, there is a neat quantum circuit version of interesting Gedanken experiments. The major drawback is that today's state-of-the-art quantum processor is very limited. The most advanced current implementations in terms of number of qubits is based on nuclear spins. The idea is to use an ensemble of identical molecules as quantum processors. The computation is carried out simultaneously on all processors with unitary operations, and the readout at the end is the expectation value of Pauli operators. One problem with this type of ensemble readout is that it is impossible to post-select in a direct way. Ideally, we would like to have a circuit element that could post-select with some probability. For example, after two systems interact, one gets post-selected in the state phi. Each time this post-selection fails, we discard the experiment and repeat until successful. An experiment where this is used is a weak measurement experiment. Here, the interaction U is very weak, and post-selection can lead to interesting and surprising outcomes. For example, an effective interaction which is much stronger than U. To implement this on an ensemble system, we use the following trick. First, we add an ancilla system in the maximally mixed state. Our post-selection is done by selectively swapping the system we want to keep with this ancilla. The swap corresponds to a failed post-selection. In our actual implementation in liquid state NMR, we used a controlled rotation instead of a swap to reduce the running time. Using a 3-qubit molecule, we were able to get a number of interesting weak values. We measured complex weak values and weak values outside the range of eigenvalues. Our technique can be used for interesting weak measurement experiments involving more qubits. The relatively large number of qubits that we can manipulate in NMR allow experiments that cannot be done in optics. More generally, our method can be used for implementing other experiments involving post-selection in NMR and ensemble-based implementations.